Okay? So not just locally, but we have from Middle East. Yun po yung mga andito mga suki namin, and I don't know, there are some students who are joining us today. Parang mga bagong names nung nakikita ko ngayon. Please behave, students. But usually our participants are coming from the Middle East, Singapore, sometimes New Zealand. And from Holo to Paris. Okay? So all over the globe. Hi, Sir Domi. Good afternoon. Na-miss kita last time. So Sir Domi is an akpe. Okay, guys. We are lucky today to have two high-ranking officers of NGT Global. Okay? The president and the CEO of the said company, and they will be sharing to us their expertise. The first speaker is no other than the president of NGT Global Digitalization. He has a 40 years experience in network system planning and design, construction and installation, operation and maintenance of facilities, customer service operation. A former senior assistant vice president in Meralco, a former general manager and head of technical operations in Ibadan Electricity Distribution Company in Nigeria with Sir Itoy Laines, maybe. T&D Power Consultant for PXI Power Solutions, Inc. He is a PEE and ASEAN Chartered Professional Engineer, kabaro mo, Sir Domi. Okay? Tsaka ni Irchitan, yung kasama natin the other week. He has an executive MBA from AIM. And of course, he is a BS Electrical Engineer. Siguro nga kaklase ni Sir Atoy ito sa UST o naging estudyante ni Sir Atoy. Kasi same project nila yung sa Nigeria. Okay? So I will know about that later. And the other speaker, no other than the Chief Executive Officer of NGT Global Philippines in RTSG Private Limited Singapore. We have some participants from Singapore once in a while. Sir Hansen is an system integrator, value-added reseller, the CEO and co-founder of Fortis Semi and OEM of Fortis TM, IoT sensors and IoT platform. 23 years experience in semiconductor industry, cybersecurity, process engineering, research and development, sales marketing. Buti na lang hindi ka ECE kundi. Okay, he is a BS chemical engineer from the University of the Philippines, Los Baños. Kasi yung expertise mo sa ECE, baka biglang meron ditong magwala ng mga taga-EE pag pinag-uusapan kasi yan joke. Mamamait yung mga EE, di ba Sir Carl? Behave yung mga EE. Minsan lang kasi alam mo na yung emotions nila kapag nagkakaroon ng problem. Okay guys, let's welcome our first speaker, kabaro natin, Engineer Carl I.G. Aquino. He will be the first speaker. And then next would be the CEO, who is Engineer Hansen C. Babae ako, Sir Hansen, ha? Joke.
Sorry po, Ma'am Chi.
Yeah, no problem, no worries. I'm just joking to make this light, okay? So now let's welcome them, guys, to share to us their technical expertise. Our next speaker is here also next week, Sir Jaime. Okay, the floor is yours, gentlemen.
Okay, good afternoon, good day sa lahat. Yes, I'm Carl. Kasama ko si former chairman Atoy Laines sa Nigeria project. He was our then managing director, and those days I was the GM for operations. Well,
hindi kanya estudyante, sir.
Magkasunod lang kami sa UST.
Galing si Sir Atoy sa akin, pinapatanda ko siya masyado. So,
bata pa kami. Okay, let me share my screen. Okay.
Sir Carl, you want me to share from my side?
Yeah. Can you please? Nagahang ako. Yeah, please. Nandiyan. Mahina wifi ko. Well, good afternoon again. Good day to everybody. Well, oh, it's moving. Well, NGT or Next Gentech Global is a company established way back in 2012 as a system integrator and value-added reseller. And it's also considered and accredited with Dun and Bradstreet service provider accredited by DICT. The headquarters is located in Marikina and with a subsidiary in Singapore, which is RTSG, the Red Team Singapore. And well, we comprise of expert personalities, and we have a strong partnership also with global vendors in the building automation system. Yes, we are a team of professional engineers, combination of engineers, different fields also. Well, our business is built on trust, speed, reliability, and service excellence. Well, NGT Global is based in the Philippines. Fortis and Red Team are based in Singapore. Fortis is actually the EOM of the highly secure precision sensors. It's an IoT sensors. And the RTSG or the Red Team subsidiary is purely for cybersecurity. That's based in Singapore. Well, our services involves cybersecurity, digitalization, software development. Okay. Based on the Republic Act of 11285, the Energy Efficiency and Conservation Act. And this is actually also looking at the Clean Air Act of which was signed in Paris by almost all the countries involved. Institutionalize energy efficiency and conservation, a national way of life, and we promote and encourage the development and utilization of efficient renewable energy technologies and systems. This act reinforces related laws and other statutory provisions for a comprehensive approach to energy efficiency, conservation, sufficiency, and sustainability in the country. And this act also ensures a market-driven approach to energy efficiency, conservation, sufficiency, and sustainability in the country. Okay. Getting the records from the DOE, our DOE, and with the International Finance Corporation, the energy consumption by sector within the Philippines, buildings comprises 36%, transportation, the LRT, MRT, all of the rest, it's around 37%. Industry comprises 26% and others 1%. This is our energy consumption as recorded nationally. Okay. Now going to in details for respective offices or establishments. As you can see, the dark blue ones this consumes more of the cooling system. 53 to 70% goes to the cooling system. This goes for the different offices, hospitals, educational institutions, residential, it's alarming, 69%. Siyempre, mainit dito. We try to keep cool also, especially with the COVID around. Retail is around 46%, hotel is 39%. And the breakdown shows also for the water pumps and lifts. These are almost within the range of 10% from the different offices up to the residential dwellings. But for the retail, the water pumps is around 30%. And for the hotels, it's almost average of 14%, both for the water pumps and the lifts. The heaters, well, it's a known fact for the hotels consumes much of the heaters. That's around 22%. Okay. And the others, more or less 2 to 3%. That's the general outlook of components of the consumption of energy, electricity. Okay. Next, please. The Philippine Green Building Code of 2015, PD 1096. Again, this is looking back at the what is happening around the world, the climate change, and the Clean Air Act. The energy efficiency, it states that we really need to improve for the buildings, for the mechanical systems and electrical systems. Now I will be dealing more on these electrical systems. Since the daylight provisions, the DOE, in particular, our DOE has released guidelines on how to mitigate and, to address this green building code. And it has three components actually. In coming up with this strategic position, DOE is trying to improve its efficiency in lighting. So they set initiatives in doing retrofitting of lighting systems in 40 government buildings. Nationwide, a distribution of 13 million compact fluorescent lamps. These are the CFLs. And the retrofit of public lighting systems, including the installation of energy efficiency, testing, and total lamp waste recycling facilities. And part of the strategy also is efficiency initiatives in buildings and industries. The establishments of a super energy efficiency service company, or the super ESCO. Later on, I'll talk about the ESCO. And this component aims to overcome the barriers to implement an energy efficient project in the public and private sectors, as well as to develop a building rating system to reduce energy and greenhouse gases in buildings. There's a particular rating scheme which the DOE has set for this. And the third strategy, communication and social mobilization. This seeks to facilitate the change by engaging a range of players in interested and complementary efforts in promoting efficient lighting and efficiency in everyday life. Communication for efficient lighting, and promoting efficiency in all walks of life. Okay. Next, please. The energy savings of building technologies, well, as categorized by building automation, technical installation, and building envelopes. The forms of measurements set, the savings derived, and the amortized years expected to recover. Okay, as you can see, for building automation, installation and optimized tuning of energy functions, optimization during operation by the use of efficient building automation and controls, and the weak point analysis, dynamic energy management. The savings, potential savings, roughly from 5 to 30%. And the period expected amortization is 0 to 5 years. For heating, ventilation, and air conditioning, this goes for technical installations. Refrigeration, lighting, controls, motors, actuators, and power generations. Potential savings, prices from 10 to 60%. Amortization years, covering 2 to 10 years. And for buildings, insulation, windows, thermal bridges, constructions, savings greater than 50%, and amortization from 10 to 60 years. By the way, the source is from Dr. Becker. Okay, next please. In Singapore, which the Green Building Code also projects for a yearly fiscal year. Actually, we got the data from the latest, which is 2020 now. The former data they had was only 2,500 buildings per project in a year, covering around 60 to 62 gross floor area. But their latest, which we got, the 2020 summary, it's around 4,000 building projects. And the gross floor area is already 123 million square meters, which is more than 42% of the total gross floor area of Singapore's building stock. Okay. By the way, for the Philippines, it's roughly around 400 buildings only. And based on the figures we have for the Philippine market, we have around 91 projects nationwide. So we are still way behind from other countries actually. But it's better to start now because the government's target, just like any other countries, as promised in the Paris Agreement, will be targeting by 2030 or to 2040. We have to address really the issue on climate change. Okay, next please. Now this is the, as I mentioned earlier, this is the super energy company. Well, the ESCO acts as a project developer for a wide range of tasks, and it assumes the technical and performance risks associated with the project. Typical services involves that are bundled into project cost. And we have here the developing stage, design, the arrangement of financing schemes, installation and maintenance of energy efficient equipments, monitoring and measures project energy savings, and assumes the risk that the project will save the amount of energy guaranteed. Actually, the cost spent for the project can be repaid through the monetary savings generated from the said project. Now, you might be asking what sets the difference between an ESCO and other firms that offer energy savings, like consulting firms and equipment contractors. Actually, the concept of performance-based contracting, or ESCOs, it undertakes a project that the company's compensation and open project financing are directly linked to the amount of energy that is actually saved. Okay, now we are going into building management system. Okay, NGT's role here is on the system integrator. From the ESCOs, this is the area. The communication link from the customers, from the different technology providers, from customers, from banks, and even government. The ESCOs considers capturing all the data needed. And we have the super ESCO that stands above the ESCO. And this captures all, including data coming from other ESCOs. Okay. Our source was taken also from Mr. A. Ablasa, way back 2019. And for NGT, we top one of our ESCOs provider is we have our partner rather. We have MServ with us. Maybe you know MServ. Ronald Torres is on board. We will be embarking on projects in the Philippines with them as our ESCO. Okay, next please. The process in getting permits for the scope to cover the building automation or building management system covers the areas for electrical, electronics, mechanical, sanitation, fire, including the fire code because of the particular regulations we have. Under electrical, you have the lighting power, transformers, the daylight control system. These control devices that can control the lighting system. The occupancy sensors, devices, again, controlling the entire lighting system. Electronically, well, we know all the controls are electronically driven also, and this goes for the daylight control system, occupancy sensor control systems, elevators, escalators, including walkways. And for mechanical, well, the air conditioning system, water heating system, recovery of exhaust air, the enthalpy of that, and elevators, escalators, moving ramps, motors, indoors, and vehicle quality. Okay, the for sanitation, we have the water efficiency overhead tanks. Water system goes for the entire building, can be for fire, can be for usage, potability. Now, as you can see, getting permits alone, it's already tedious. But we have to abide with rules and policies on how to address the proper documentation. Okay. Next, please. For us, building automation, why NGT? Well, creating the perfect place to improve people's lives by providing the latest technologies in building automation and building management system. How? We being a trusted partner to our customers. We're the leading and preferred system integrator for high performance, safe and efficient building. Well, in the market, we have a lot of integrators, but suffice to say, we are at par, and with the technologies available, we can be, and our product offerings and knowledge, this is what we carry. Okay. And I'll let Engineer Hansen continue.
Thank you, po, Sir Carl. Thank you for that wonderful overview of the concept from ESCO down to savings, energy, para sa and then going into the building management automation system. So yeah, so yun yung pinaka-background ng building automation system is basically, in short, just to make it, to recap what Sir Carl shared is basically to save energy. And sabi nga, the other day, we just attended a seminar with Senator Gatcharan also. And he mentioned that energy, a megawatt saved is a megawatt generated. So that's why the Philippines now is pushing for saving energies. And ang pinaka-key talaga is the energy efficiency technologies. Now, I want to give you an overview of the building automation system from the top down to the details. Okay, of course, we don't have time for all the details, but I think yung major components that can really make the energy savings happen for a building. So we're talking about, the Philippines and Green Building Code is actually talking about 10,000 to 20,000 square meters and above. So when you have those types of gross floor areas, malls, retails, hospitals, those are really candidates for energy savings. And even sa, I think Laguna, there's a lot of industrial estates napakalaki. They're really huge and they use a lot of energy. And if the what do you call this, the energy consumption is really huge, maybe 100,000 kilowatt hour per year, then those are really candidates for building automation. Not saying that even the small and medium sized building, kailangan din nila ng building automation. As you can see from the previous slide with Sir Carl, that is a small building actually that they did the study, but with the room automation, they were able to show how much savings you can generate, in fact, by just adjusting this, making them variable. So if you look at this slide, this is the complete system architecture of a building automation system, or what we call building management system, or some people call it building management and information system. So you can call it many names. Some people also call it just a direct digital control system or whatever. But basically the heart of it is the software. So if you got the software, a dashboard, meron kang engineering room, and then you can see all the parameters from your control room. So that is why the heart of it is the software, and that is integrated with many different layers of hardwares. So starting from the mechanical and cooling equipment. Ay, hindi ko po. Okay, and then of course kasama dun yung chillers and cooling towers, the PACU, precision ACU or AHU, the fan coil unit, ito pinaka popular sa mga older buildings. So these are also candidates for retrofit. You know, retrofitting older buildings. In fact, sa Philippines, Singapore has done that a lot. Sa Philippines, we have a lot of older buildings and they are really candidate for retrofitting. And what can energy efficient technologies do is implement this maybe variable frequency drive or VSDs, variable speed drives, which, you know, depend this demand and flow, you can adjust all of these parameters. Also, it has to be able to integrate to the electrical components, katulad ng lighting system. So, as mentioned by Circle in the Green Building Code, lighting is one of the focus areas where energy savings can be realized. So, depende sa demand ng lighting. So, kapag walang tao, kailangan ma-turn off. So, you can't just rely on manual turning on and off of the lighting kasi mahirap. I mean, you can't just do it. You can't do it without automation. And then, of course, meron kayong pati yung security and then the access controls. These all have to be integrated. So later on, at the end, maybe towards the end of the presentation, I will show you some of the, talk more about the trends in BMS, okay, the system that allows for us to really save and be able to come up with energy savings projects for companies. Now, at the heart of it is, of course, total room automation. So if you can create that system and be able to put together the sensors that will allow you to determine yung mga different environmental conditions and how it would affect. Kasi you have to improve the quality of life. Yung air quality, you have to improve it. Yung lighting condition, you have to improve it. The coldness of the room or coolness, you have to adjust it depending on the demand. So that's the top level. You integrate that together and you have a very powerful energy efficient technology, which is called the building automation system. It's not new, building automation is not new, but it continues to evolve. And people are coming up with new technologies, new hardware, new software technologies. Even the software today, 3 years ago, is not available because they've now been able to really become very open. Maraming protocols tayo. Later, I'll talk about the protocols also. May mga protocols na dati proprietary from 1970s down to 2000. Now 2010 and 2015, they're all talking together. You just buy converters for these protocols. You need to master one, but to integrate that with other protocols, you can actually obtain these converters so that they can talk to one another. And then you can integrate it into your software, your building automation. So later I'm going to talk about the system controllers, just a little bit, just to give a background, technical background for the rest. Not too in-depth, we're not going to go very deep into that or else it will take us a lot of time. Also sensors, I'll talk about a little bit of sensors. This is total room controllers, automation controllers. So in some vendors or suppliers, they've actually engineered these to a point that you can really integrate that, have a total room automation by lighting and also integrate that with the valves and actuators and damper actuators, as well as the VSDs for the fan coil units, okay? And of course, without the thermostats, it's impossible to adjust the temperature, modify that according to the occupancy needs. So it's been found out if you are actually if you engage the occupants in the energy efficiency savings or in improving energy efficiency, you will be saving more. So that's why later I'll show you a little bit of total room automation. It's a short clip, short video. And if you engage them more, that's why it's very important that all of these hardwares we understand as engineers and we know how to put them together so that we can have a really energy efficient building. In Singapore, they're now talking about super low energy buildings, so SLE na. So it's not just low energy buildings, but they are really, it's like saving 80% of the energy than their benchmark in 2005. So they're really pushing forward. And with the use of these technologies and machine learning and artificial intelligence, they can go up to super low energy. So Philippines is catching up and we really need to learn all of these technologies. And in fact, we have to be on top there and also contribute to the technology advancement of these building automation systems. Okay, as I mentioned, yung building automation systems, you can put them together so that you have a total building management system that you can integrate the safety, HVAC, security, power, and lighting. And because there's so many other vendors out there, so many different brands, so many OEMs. Nowadays, the trend is to be open, have an open protocol. So you gotta choose something that is open in its hindi siya proprietary. So open, meaning you can integrate other protocols. Later, I'll talk about the protocols. And of course, the energy saving solutions did not happen overnight. So people has been improving the PICV and the VAV. And when PICV, that's the pressure independent control valve. So, parang it gives you a constant pressure kahit na may leak or merong ibang pressure, ibang flow of air, or usually this is more for hydroponics. Sino ba sa inyo ang nasa malalaking factories that is involved in chilled water using hydroponics? This is usually used for that. And then VIV is for the variable air volume flow. So syempre, if you shouldn't be pumping in cold air in a room that is empty. So these are some of the technologies that you can integrate together. And of course, PICV for AHU, and you have digital AHU as well. And sa energy savings of a building, one of the key technology that must be really scrutinized or changed or upgraded or modified is the chiller. So yan ang pinaka-importante sa generation. That's about 50 to 70 as Sir Carlos pointed out. A lot of energy savings can be realized from having efficient controls in the chiller plant rooms. So as I mentioned, there are so many other protocols, and you have to choose a system or put together a system. And we've learned this as a system integrator, that there's so many protocols: BACnet, Modbus, OPC, KNX, MBus, SNMP, ONVIF for cameras, and IEC protocols. And you have to have a really good graphical user interface that combines everything. And of course, yung hardware and software must talk to each other. And importante, much more important nowadays, is cybersecurity. As you can see, in the past 2 years, there's a lot, so much ransomware attacks in the world. Yung US continental pipeline, so they've been attacked, and yung Florida water. Sa Philippines, not much news, but I think it will come out, like yung mga leaks, data leaks ng National Statistics Office and so on. So meron a lot of what do you call this, threat actors is very active nowadays, that tayo ay nasa, what do you call this, pandemic, at parati tayo nasa online right now. The digital usage has been tremendous. That's why NGT is also into digitalization, because the world is really forced to transform digitally. So pati yung buildings, and as I mentioned, yung driver talaga ng energy efficient and digitalizations in the building is because we can actually save. Can you imagine saving like $1 million per year on your building with just installing building automation system and energy efficient technologies? So those are the drivers. So I think what we need to learn are the protocols. If you're really a hardcore engineer, you want to learn this, and I'm just going to share one protocol. It's the BACnet. I'm pretty sure many of you, or if not 100%, you knows about BACnet, because this is like 60% of the total market in the building automation is using BACnet. But it's not saying yan ang pinakamagaling, but also Modbus and the other protocols, as I mentioned, they can talk to each other. So today, you really don't have to worry about learning just one protocol. In fact, since they have similar, what do you call this, layers or similar builds, then it's easy for an engineer to adapt to one protocol to another. So if you learn one, parang mga programmer, if you learn one programming language, you can easily adapt to another. So kung marunong ka mag-Tagalog, you can adapt to Chinese. Madali lang. Okay, so that's .NET protocol. Now, as I mentioned, of course, this is usually integrated into an architecture, total architecture. And as you can see, yung mga nasa field level 0 is what we call the Purdue level. You can check it out, Purdue level. On the southbound connectivity, you can connect all the fire safety and security technologies, plus the energy and comfort technologies like the heating, cooling, air conditioning, pati yung shading and lighting, as I mentioned, including the power management. So all of these talk in different protocols or communication protocols. Okay. And you have on top of it is the management level, where you sit in the control room, you have the dashboard, you can look all the parameters, different parameters in each of the section of your building automation, from each AHU chiller up to rooms, okay? And all of those are installed in the server. Okay, and then they talk to other front-end processors. Front-end processors just basically small computers. You can say that these are some of the DDC, also direct digital controls. They talk to one another. These are somehow distributed in many different parts of the building. And then they all talk to a central location control system, which is the management level. So it's complicated if you have a huge building. It's complicated if you have, if you are really saving energy for the company, because you have to really determine a lot of set points, mga temperatures, outside air temperature, inside air temperature, pressure ng bawat location in your building of the pipings. You have to think about that. So there's a lot of engineering work. So yung IIEE will never run out of jobs. Sabi ko nga in my previous talk, IIEE is really, I mean, electrical engineering is one of the I think the biggest engineering this segment in the country. So on top of that is the northbound connectivity. That means you can access it anywhere, anytime. You can integrate this with other software. So it's beautiful now that you are not like restricted to one technology or one vendor. As a system integrator, you can do a lot more, or as an engineer, because you can make them talk to each other. And you can use APIs to create really beautiful dashboards, graphical user interface that can make your life easier. So in fact, in domain of information technology, in programming and so on, are very important in building automation. So you gotta have people who knows how to integrate them, learns the language of the Modbus, of the BACnet, and so on. Also able to create applications, mobile apps and smart apps. So importante yan for building automation, because you've got building owners who want them in the fingertips. In fact, if you're a building owner with like 10 to 20 buildings or more, you want to see your situation of your buildings in your mobile phone or your tablet. Yan ang mga requests in some of the companies that we are talking to. Ang request ng owner is that I would like to see all the cameras in all my 10 buildings. Okay, so can you do that? Okay, so yun yung mga issues ngayon. You know, they want to exploit, because you know there's so much you can do with the software, and they know you can push that envelope. And ang dami nating and daming new technologies that are coming in, and this will be improved. So you can't say we're stopping here. There can be new protocols that are coming out in the future. But in the basic of this building automation system is in fact the input and output. So there are 4 types of sensory informations that makes the building automation happen. So meron kang analog input that detects analog input, and you have those sensors there for temperature, humidity, pressure, and so on. And then you can also have the digital input. So kailangan mo ng open and close valve, all right? If is the air flowing, how much air is flowing, you want to detect all those, and then you want to put that inside your building automation system. And it is a component, a very important component. Meron din tayong analog output. So it means it controls the speed or position of a device. This is most especially true for variable frequency drives, VFD and VSDs, and especially for a current to pneumatic transducer or a valve or damper actuator. So an example is a chilled water valve opening up 25% to maintain a set point. You know, so these are the digital analog input that must be there. I mean, that must be detected. And the digital outputs are used to open and close relays and switches. So an example would be to turn on the parking lot lights when a photocell indicates it is dark outside. So yun yung digital output naman. So there's so many examples, and I think throughout our career, you will really see that these are the basics of input-output in BMS. Okay, hang on. All right. Now I want to introduce also the importance of the sensors, because for these sensory outputs, the problem today that we're trying to solve, or what the engineers are solving, is napaka-mahal ng installations ng mga sensors na ito, right? Because you need to do the layout, the cables, the wirings, and there's a lot of brain power that you need to do the layout and so on and so forth. So today, the buzzword is IoT. In fact, it's the same as instrumentation. It's just that now we are moving into Industry 4.0 and beyond. So now it's more wireless, and we have, as a Philippines, it's also 868 megahertz, meaning that it's sub-gigahertz. And ito yung mga lower data rates, but farther and able to use IPs also. So we have sensors, we have developed sensors in Fortis itself. We have 100 plus sensors that's with batteries, AA batteries, coin cell batteries, and they talk to gateways that we have also developed. And then these gateways direct the data to the online platform, our online platform, and it can be also on third-party platforms. So ngayon, it's like 60% of the world is running on cloud, and it's going to increase, right? 40 to 60%. And mostly, dati parang we are so afraid of putting our data on cloud. Now it's like everybody's on cloud, right? Or almost everybody. It's gonna explode in the future. There's no way for the world but to transform itself digitally. That is why we are into the digitalization game as well. But for those who are more traditional, of course, and those companies that has the ability to have their own secure network, they prefer the on-premise solutions, and we also have softwares for that. Now, I want to highlight that one of the issues why some of the ESCOs are unable to put more sensors is because, number one, it's expensive. Number two, if they have wireless sensors, it's only limited to a few of sensors, one gateway to a few sensors. But we have made it so that you can have more sensors. So those are the things that we have thought about. And signals can pass through 300 meters away. Of course, that is true for long range RF communications. Yeah, and it can pass through walls. So sometimes we're asked, can it pass through ano ba? Kasi sometimes in cold storage, it's metal cage. But we have found out signals can pass through because there are, like, alam mo yung gasket sa refrigerator natin? There are gaps there, and it's my magnet, and then there's a rubber there. So even signals can pass through that. So it's not an issue really. If you have some to test in wireless solutions for sensory input into your building automation system. Okay, and also since these sensors, of course, will only work with building automation system yung software mo with the controllers, and it also speaks the language. So we also have the Modbus protocol in that. Hindi lang APIs or the webhook APIs or RESTful APIs, but also yung BACnet and Modbus. But in fact, we have came out with a Modbus, and of course, depending on the engineer, they translate that to a BACnet. Now, I want to also highlight na importante with your wireless sensors, they have to be able to function for long periods of time, maybe let's say 12 years. So yes, our sensors can last for 12 plus years depending on the heartbeat, meaning the frequency of the transmission of the signal. So you can have that set point. So an engineer is in fact responsible for transmitting those signals, right? So you can vary the life of your battery, and of course, it tells you, your system must also tell you kung malapit na ba maubos yung battery. So meron dapat yung battery life indication. So meron din yung system na ganyan. So those are the things that you need to consider for choosing a sensor and wireless gateway. Do you need to, kasi for some areas where there's rural areas, for like factories, huge factories, I think in Laguna, huge factories, sometimes you will need cellular gateways also. So you have different types of communications you must use for this. Okay, so again, and benefits of using wireless is that you can install more sensors, better for total room automation or for building automation systems, and then you can lower the cost of installation. And in fact, it's very easy if you choose the right systems for this to complement your building automation. Of course, as an engineer, you can't brush away security or your IoT security or cyber security. In fact, today's engineers, everyone must be really, what do you call this, aware and have a know-how in choosing the right technologies for the sensors as well as for your building automations. So there's a lot of hacking that's happening nowadays, ransomware. Some of them, in fact, kalimutan ko kung anong, but they were hacked through a sensor, IoT sensor, in a fish tank. But anyway, through the fish tank, because they were not using advanced security systems. So we made sure because Fortis also is using the latest, the greatest, very hard to hack. Okay. In fact, we are using a bank grade securities system for our sensors. So meaning from one point to another, there can be no man in the middle. So cybersecurity and tawag doon is you're hacking, you're listening to the signal between the receiver, the transmitter and the receiver. That's called man in the middle attack. So yan, sa espionage, ginagamit yan. And then so we use the frequency hopping spread spectrum. That only means that, only the receiver is able to know kung ano yung kung saan na pupunta sa frequency band yung transmission, right? So they are in sync, so the man in the middle cannot know. So meaning also it is a what do you call this? It is also a feature for anti-jamming. Okay, so they cannot listen to you because you are hopping from one spectrum to another, from one frequency to another, I mean. So we have also incorporated Diffie-Hellman key exchange plus the AES-128 CBC. Okay, so the Diffie-Hellman, now it's called Diffie-Hellman-Merkel. So this was invented in 1970s, 70 plus, but this is used widely in encryption for public systems. Okay, so the AES-128 is the advanced encryption standard. It's a symmetric block cipher chosen by the US government to protect classified information. So now it's used in World Wide Web, AES-128. So most of our technology in encryption comes from the US, some in Russia, and all of this. So I hope that the Philippines next time can come up with all this encryption. Coming up are the quantum mechanics. So for that, I think it's a very green area where our engineers can go into for encryption technology as well. Okay, so but anyway, this is just illustrating the AES-128 CBC. That is the right. Okay, so I'm not going to go into the details, but that just illustrates your encryption between your wireless sensors and then the gateways. And then of course in the TLS level, ito yung ginagamit natin from browser to the server, right? From computer to computer, and that is called the transport layer security. Now, it's meron yung handshake, and then they talk to one another kung anong klaseng cipher ang gagamitin or cipher suite ang gagamitin. Okay, so I think it's a whole lot of subject to discuss, but I think we don't have the depth to discuss that today. Now, just for your information, there's a lot of wireless sensors out there. In fact, if you can think of a sensor that's wired, most probably there's a wireless sensor na kasama niya. So, you know, from temperature down to accelerometers, all of these different sensors you can use for building automation. So depending as an engineer to specify and what types of sensors he's going to use for the building automation. But these are available, and yeah, you can really implement this in your systems. Today, I know a lot of us here, about 346, a lot of you are working in companies that are lacking in these technologies. You've got Source, we can help you out also. As a use case in HVAC, so you can use temperature sensors, duct temperature sensors for the air handling unit, AC current meters, so that you know kung there's abnormality in your motors that's drawing a lot of current. So you know that, you know, sometimes, syempre, pag tinurn off mo, this is very popular in electrical engineering. I think in our electrical engineering modules, tinuturuan tayo when you switch it off, there's a lot of spike. This is not for the spikes, but this is for the constant monitoring of when it comes down, and then you constantly monitor. And then when there's a spike, meaning there's a problem with the belt, right? So that you can use current meters to detect that. And these are very useful for predictive maintenance in IIoT or 4.0 in IoT 4.0. In fact, yung predictive maintenance is the buzzword. Okay, I know a lot of you is in preventive maintenance, but even Singapore is grappling or also moving into that space. But I haven't seen, there's not many, what do you call this, installation. Meron na, but still not widespread. Okay, so even the big pharmaceutical companies here, we're talking to them, and they really want to move to predictive maintenance, but I think cost is the issue. So vibration meters, that tells you also can be used for HVACs and differential air pressure sensors. You know, you want to find out whether you've got air between sections and then between your filters in your AHU. So you want to put the differential air pressure sensor. So there's so many sensors that you can think of, can put it there. It will make a difference, because if you have all this data, then you can be intelligent in saving energy for the building. As I mentioned, ito yung top 3 sensors that is used for predictive maintenance in a motor. Okay, you've got the current meters, you've got the thermocouple sensor for detecting the temperature. Kasi when you've got abnormal spikes in temperature, that means overheat na, you can find out, yeah, okay, it coincides with my vibration. That's why there's a lot of vibration. So all of this, you have got to have the complete picture. So hindi pwedeng half blind tayo. No? So kailangan buo yung picture. That's why these are the usual sensors that are asked by our ESCO customers, energy saving company, that they want to implement into their building automation system. Okay. And of course, this is also used for independent monitoring solution. You can use that. Sometimes BMS in itself solution, okay, you look at that, it's not enough. So you want to audit, you know, my third-party audit, you want people to, tama ba yung, is our system breaking down or not? So you gotta have a separate monitoring solution for that. So in fact, if you put in a building management system, if you don't have a monitoring solution, also, you know, just to double check, kasi sometimes you fit in all of those PICVs, you fit in all of those, mahirap tanggalin yun, mahirap i-check, you know, you don't want to check it out, yun, ayaw mong tanggalin, kailangan ma-check mo muna if it's working or not. So with a third party or the secondary monitoring solution, if you got a local solution, this wireless solution, then you are able to engineer it properly, or what do you call this? Analyze the root cause properly. Okay, so in fact, these are legislated in GXP compliance. So if some of you are working in the pharmaceutical industry in Laguna, madami yan na pharmaceutical dyan. So I'm pretty sure you have monitoring solutions there, right? So for your compliance. So those are the uses. So all of these sensors, input and output. That's why IoT is the buzzword, because you want to save energy, but with saving energy and all of these engineering aspects in root cause analysis and so on, you want to have the right sensors, the right solutions, hindi madali ma-hack, you know. So that's the short introduction to IoT sensors. So let's go on to the system controllers. As I mentioned, you've got your software, then you have the system controllers. These are distributed all around the building, depende kung sa anong system ang iyong ito-control. Sa ACU, AFUs, sa ACU, sa HVAC mo, sa chillers, and so on. So this it looks like this. For those of you who haven't seen a system controller, some people call this the direct digital controller. And these are the different, what do you call this, components, all right? So you've got here Ethernet connection down here, which connects to the internet, and you've got the input and output channels. So you can connect all your sensors here. You can connect the output channels here so that you can vary your dampers, meaning close open ang mga valves nyo. You can vary the pressure and so on and so forth. So this is where you connect all those wires, no? So mahilig tayo as electrical engineers, mahilig kayong mag-connect ng wires, the integrity of electrical systems. So this must pass all the certifications and testing and standards, ANSI, IEC, all of these standards, Philippine Standards Board, all of these products must pass yung mga yon. So you gotta choose and select the vendors that pass this, so you don't just select yung new entrants, new entrance vendors, because this is becoming a huge market. So meron kang syempre startups and so on. And make sure na you check whether they have complied with all the compliances in the standards. And you know that very well because professional engineers is a highly regulated profession. Okay, so just an example of types of DDC, there's the fixed function, configurable, text programmable, graphic programmable, and a combination of all of these. Sabi ko nga, these are evolving. So it means that it could be obsolete na, maybe in 1 or 2 years, because they've come up with a new DDC controller, maybe with artificial intelligence. And sabi ko nga, quantum mechanics will come later. So ma-obsolete na rin ito with the new technologies that are coming in. And I'm pretty sure even photonics, silicon photonics is coming up. They will be using neural networks and whatever have you, even ibig sabihin photonics, using lights. So electrical engineering using photonics, that's also possible in the future. Okay, and as I mentioned, these system controllers, they talk to one another, right? So you've got the master and the slave, and maybe, I think you just interconnect these system controllers with one another. And they talk. The drivers is using Modbus and BACnet and so on and so forth. Okay, so they're distributed all around the system. So there's a lot of engineering work you need to do sa specifying this system controller. So daming trabaho ng engineer, no? And of course, you need to understand. For example, ito is just an example of a variable volume air handler unit. And this could be so many in 50-floor building, commercial building, office. You gotta, marami siguro kayong VAVs niyan, or in some cases, pwedeng konti lang. So this is a small VAV, air handler unit, but small as it is, there is about 20 of these point description, input, output, what you need to check for input and output. So you have to know this very specifically. Magkamali ka dyan, sayang yung inyong installation. Pero kung meron ka mga installation na ay kulang ang aking input, okay, you can use yung mga wireless sensors as I mentioned before. So a lot of the, meron na yan, some of the buildings in the Philippines, most of them have some of these controls, but I think underspecified or kulang sa input, kulang sa engineering work, meaning you can still optimize. Okay, so when you want to optimize a system, you gotta add more. And that's why meron tayong mga wireless sensors that can add more sensors input beyond this that you've already specified. Okay, so you gotta know how to specify this as an engineer. Now we come to the total room automation as a use case. So I've shown you the overview system architecture down to what is really making the building automation work, down to the system controllers and so on. So now I'm going to give you an example ng total room automation. Okay, so from the study that was done by the Biberach University kay Dr. Becker, as Engineer Carl has shared later. Ito na yung mga what is in the market and also being integrated nowadays. And I think every building must have, because it really saves energy. You know, it's been proven in academic world, in research, in R&D environment. It's been proven in energy savings projects, especially worldwide in first world countries, the US, Singapore, and in the Philippines with 91 projects. And this must be a norm. I think magiging natong norm in our engineering work. So total room automation is a norm, and it will be improved more, right? So, but this is just a video that you can I can show you. Okay. Okay. Hang on, I think I'm just gonna restart it. Just hold on the sound. Give me a second. Okay, let me just restart. Okay, let me know if you can hear this. Okay, so I think that's it for that one. Let me just go back to the slides here. Share. Share. Okay, you see my slide? Hopefully, no? Okay naman, ano? Okay, thumbs up. Okay, good. Okay, so moving on, that's just a sample of how you can do total room automation. And basically, it's a very simple concept. Just make everything variable depende sa demand. So meaning it's a demand control or demand supply. So kapag konti yung tao, you adjust the air intake, you adjust the lighting kapag walang tao. You know, a lot of the, kaya itong mga automatic lighting sa mga CR, sa toilets, no? Kailangan ma-install na yan for lighting. Mga sensors to detect whether there's a light or not, to turn on and off. In fact, even in our homes, if you can buy that, the savings for energy far outweighs, in fact, the initial cost. So that's why meron ka talagang years of, what do you call this? Meron ka the investment and then you recoup the investment later on. So meron ka talagang payback period, as the slide engineer ni engineer Carl, for this. So that's why nabuo yung business ng energy savings, and hindi lang just a business, but because as alam natin, energy savings is the underlying reason kung bakit we are moving into this total room automation. It's really to save energy. So in your, maybe if you are in the management position or in the building owners kayo, you're in this space or you are able to influence management or new buildings, really advocate for it. I think as engineers, we should advocate yung mga economical na mga technologies. And we are, as engineers, yun ang importante. Because, again, sa simula ng ating courses as engineers, engineering is making science and the technologies cheap as much as possible or economical. Na nagagawa yung talagang, what do you call this, objective niya. So that is who we are as engineers, right? So you can vary the outside air intake, as I mentioned, and you've got the lighting control, you've got CO2 sensors. All these different sensors can play a part. So you can install different wireless sensors and connect that with a thermostat. So these are how to build energy sensors, energy efficient rooms. You can't do it with sensors, without sensors, I mean. Okay. So also, I think the majority of the savings that a building can have, as mentioned by Engineer Carl, is in fact sa cooling system. So makita niyo naman yung maraming different sectors, and what is common to them is that 53 to 70% of the energy is consumed by the cooling system. So you gotta attack that which is the majority. In Pareto principle natin, 20%, 80%, you attack that 20%. That can give you the 80% benefit. So you attack this HVAC system, and you know the underlying issues. As engineers, we know the root cause ng mga problema ng mga to. And it could be a flawed system design, old design, inefficient design, and then adoption of poor practices. You know, walang budget, kaya yung bahala na. Dalawa lang yung tao, wala kulang sa maintenance, walang budget sa sensors. Now you gotta create something for your management if you're working in a company, so that you can sell the idea. Hey, we are doing all of these things. Meron namang predictive maintenance we can move into. In fact, it far outweighs the benefits of the preventive maintenance. You can put in new technologies so that you can save a lot more in your energy. So as I mentioned, ang solution dyan is demand flow. Gawin mong all variable yung chiller mo. From the special showing you a hydroponic system using water to cool the system. These are mostly used in bigger buildings, hydroponic system. It really save you a lot. And you gotta use new technologies for these types of system, no? So importante yan, as an engineer, look at the optimizing the HVAC system. Okay, so this one, I'm pretty sure a lot of you knows this. Ito yung chiller plant efficiency spectrum. No? So yung mga older buildings have chiller plants installed, matagal na, and they don't really care about saving energy. Basta matayo natin yung building, okay na. So that's why all these chiller plants need to be improved. And as you go from the right to left, means left is excellent, really efficient. So if you look at the COP, or coefficient of performance, and EER, or in some cases called energy efficiency ratio, or kilowatt per ton. So these are different terminologies, different units, convertible naman sila. They describe the heating and cooling efficiency of air conditioners. So they indicate in ratio of heating and cooling provided by a unit relative to the amount of electrical input required to generate it. So when you go to new technology using all variable speed, this is the upgrades that must be done. So yung mga older buildings, hindi lang ito applicable sa new buildings, no? Although the green code building is only applicable for new buildings, but in fact, there's a lot more savings we can do if we can retrofit yung older buildings. So ito yung technology, underlying technology there, the variable speed controls in the chiller plants. So if you can install all of these new technologies, then you have to, so that you can have better efficiency and energy savings. Okay, so this one is taken from ASHRAE, the American Society for Heating, Refrigeration and Engineering Association, something like that. So, meron ba tayong ano dyan? Counterpart sa Philippines? ASHRAE? Mukhang wala, no? I don't know. I'm not very familiar kung meron tayong counterpart dyan. But this is what is used for green building codes, that they, in fact, as a measure of energy efficiency. So if you've got a COP of 7 and above, you are really very efficient. So if you look at the different types of chillers, centrifugal chillers, you got the comparison between the variable and the constant speed chiller, which is very popular in older buildings. You can see, because most of these chillers, in fact, operate at 40 to 60, especially now, pandemic, mas mababa pa yan, maybe 20 to 40 or so on. So depende sa demand flow. So really, I think it has been settled with a lot of R&D works and real world cases na variable speed or variable or demand flow trumps yung constant. So when you do the design, don't just design blindly, no? You really need to consider yung variability, yung demand flow supply. Okay, so this just means that on the left-hand side, right, for every kilowatt of electricity you put into the chiller system, dapat maglabas siya ng equivalent ng 8 kilowatts of refrigerant equivalent, right? So that's why if you have a higher COP, that means yung system mo is more efficient. So if you want to have an efficient constant speed chiller, kailangan nasa 100 plus ka, 90 to 100 plus, right? That's when you can really maximize yung chiller mo. But ito, I think we're talking more about the mechanical side of it. Very seldom that you use 90 to 80% of that. And then you overdrive it and masisira pa yung motors mo. So you've got a lot more problems there. Okay, so I think these are some of the shortcomings in chilled waters, and I know that this is more on mechanical side, but just to highlight in delta T syndrome, when you encounter this, some people perceive that you must add more chillers, you know, palitan yung ganito, lakihan yung specifications and so on, and you'll have trouble, that you're not gonna save a lot more, but you are just putting in more cost. You know, so hindi ka cost effective if you encounter this. You gotta understand that T syndrome, and chilled water reset, and so on and so forth. Okay, so these are some of those. Excessive energy consumption is due to excessive chiller lift, bypass of chilled water flow, constant volume pumping, untuned chiller water control system components, non-optimized cooling towers, inefficient and overly complex sequencing. That's why today I've seen some technologies that are using artificial intelligence so that it can be efficiently sequenced. Kasi sa building automation, ang pinaka-importante sa engineer, dyan is the sequence of operation. So you gotta know your sequence of operation ng whole refrigeration system mo. So kapag very complex yan and it's may mali ka, then you are actually consuming more energy than in fact saving it. So kailangan mo ng tools nowadays, machine learning, artificial intelligence, and a lot more sensors for you to be able to really save energy in the system. Okay, so of course, when you have a poor chilled water system, as I mentioned in the video earlier, you will have poor environment, pangit yung cold, productivity will reduce. So a lot of the business aspect, in fact, itong mga intangible business benefits, that's not hindi pinapansin ng management when you talk about improving your systems, no? So that's why some of the a lot of the siguro projects that you want to the management of the company or as a building owner to put money into, hindi nagma-materialize. Yan ang problema natin, no? But if you're a believer, if you improve the well-being of the employee, then you will also invest into this. So it's not just energy savings, but also the comfort and productivity, increase of productivity ng occupants, ng employees. So when you have, of course, kasama na dyan, when you have overdrive of the system, you will decrease the equipment life. So imbis na you can really make it work for 10 to 12 to 15 years, it becomes like 3-4 years, palitan mo na. So mas marami tuloy ang yung cost dyan in your system if you have poor design systems, no? And so another shortcoming is inability to measure and maintain subsystem performance. So your inability na yon is because high cost of sensors, high cost of installation. Wag na, pagpaliban natin for next year's budget. So this year walang budget, but in fact, if you had already invested some money there so that you can accurately, precisely maintain or measure yung mga performance, you would have saved more, especially on the energy and also in your maintenance, in your spare parts, right? Okay, so this is just a yung energy savings with optimized chillers. So you go down from all of these major components of a chiller system, from AHU fans to cooling towers to CW pumps and chilled water pumps and chillers, then you will see that there's a lot of savings, up to 50% in total system energy usage. So data speaks for itself. You know, that's why the ESCOs are here, so that these initial investments that are huge can be amortized over the years. Okay, so you amortize them and you will have a beautiful energy saving system for your building automation. And of course, you must use simulation and data analysis for that, right? Ngayon, ang daming software, very powerful software that are using algorithms, new algorithms. So hindi na tayo mano-mano in calculating efficiency, and even looking at this before even implementing the solutions. No? So you got to use softwares in all of those endeavors or in your projects for building automation. Use them well. An engineer should use all of these available tools. As you can see, yung base plant efficiency, dapat alam mo yan. So that is done by auditing the energy consumptions and in the COPs for the chillers, for example. So those audits are done by the energy savings companies. May baseline ka. So now you want to simulate itong light blue color, and then you want to measure the after effect after implementing or commissioning or installing this energy efficient technologies. And you gotta have this data on hand, ready. And in fact, the Philippines is collecting all of this data, as well as Singapore has been collecting this since 2005. So, and this just improves, as collective engineer, it improves the technology, Okay, so sa atin, we do a lot of sharing. We must use all of this data sharing, in fact, amongst our community, in the engineering community, so that we can improve much more for the well-being of society, as well as, of course, energy savings pa rin, ang ating pinaka-goal, right? Okay, now I'm going to the last portion of my talk is basically on the trends on building management software. So in the past, as I mentioned 2-3 years ago, all of these are separate. So you've got softwares for HVAC monitoring, you get softwares for security system, meaning for the CCTVs and intrusion detection. Intrusion detection, you also must have like sensors, IR sensors, right? Lighting control systems, yung mga PIDs, and you gotta select all of those. You've got different control systems for that, lighting control system, occupancy system, power monitoring system, FDAS, or what we call the fire detection and alarm system, another software for that, another software for total room automation, another software for access control system. But now the trend is you gotta put them together. So there are technologies that has put them together, vendors has been able to put them together, and those are the things that you must implement in your building automation system, because you will need those. Kung ngayon wala kayong budget, baka 2 to 3 years down the road, magbago ang ihit ng hangin, and you will need a new direction, and you need to integrate them together. So in fact, since available na siya ngayon, why don't you just already buy or put together or implement the solutions that are already there, yung top of the line or the latest and greatest in the market today. Okay, so yan ang pinaka-latest trends in the DMS softwares. And of course, it should be able to also support the new subsystems. So ngayon, ang dami mo nang kailangan ng nagbabago rin ang business, climate and business models. It also changes, and in fact, kung sa bahay, small na bahay, pag pinarenta mo, hati-hati kayo ng consumption ng energy, but in a huge building, hindi pwedeng you divide it equally. Dapat kung ano lang yung consumption. So you gotta install a lot more meter for that, water meter, power meter, also BTU meter, meaning for cooling. Kung ano lang ginastos mo, yun lang babayaran mo. So this is becoming a norm na kapag nagtayo ka ng building, parentahan, office building, especially the huge ones, and even in the malls for retail, kung ano na yung ginamit mo, yun lang babayaran mo, right? And of course, meron ka ring software for meter management. So the software also has to see this in a different, for the different meters that you have. So for engineers, you will install thousands of these meters in huge buildings, and how to do it manually, you cannot. You need to use software solutions that can help you. So napaka-importante ng meter management, right? And I know that all of you know this, that you have different metering technologies out there in the market, and you can use different protocols. You can either use wired solutions, you can also use AMR or automated meter reading. You can use a data concentrator, lakad ka around the building, near the building, and magbabato na siya ng information sa'yo. Or also you can use, nowadays it's mostly for automated advanced metering infrastructure. They talk two ways. So you can turn on and off the meter. Kapag kanina nagbayad, turn off ka. Okay, so but these systems AMR, one way lang yan, one-way communication, radio communication. So these are some of the things that you must select in installing all of these meter technologies, which is part of the energy savings, energy conservation. Because you see, if the tenant is aware of his energy consumption, edi syempre, he won't turn on the AC 24 hours a day. He will be forced to, teka muna, malaking binabayaran ko, I'll turn it off. Diba, sino sa inyo nagpaparenta dyan, no? When we rent out, I used to rent out my room. Syempre, kapag ka 24 hours yung aircon ng tenant mo, yari yung bill mo, pati ikaw, dala. So simple analogies, but this is also what happens in big buildings, right? So you can do this with advanced technologies, energy efficient technologies. and understanding the protocols within that. So you got to understand the system architecture, understand the components that is used to make those things work, and of course understand all of this in a business point of view. Really, you got to save. So all of us engineers, tayo ang leaders ng engineering sa Pilipinas, we have to cascade this down sa ating mga upcoming engineers, especially may mga students pala dito that I know of. This has to be the norm already sa Pilipinas. Can you imagine 350 engineers here today implementing all of these technologies? Marami tayong masisave na energy sa Pilipinas. Again, megawatt of energy saved is a megawatt of energy generated. So tulungan natin ang ating bansa. So with that, I think that I will close here. That our energy efficient technologies actually enable engineers to create the perfect place. So isa yun sa ating kailangan matutunan as engineers as well. So that's the whole presentation today. Thank you very much, Ma'am Chi, and all of you in IIEE for allowing us to share a building automation system for energy savings. Okay.
Yes, thank you also, Sir Hansen, for the accommodation, and we hope that we can have you again in one of our webinars, our Thursday Delight. Again, guys, the floor is now open for the question and answer portion. You can just directly unmute your microphones to direct your questions to Sir Hansen. Okay, guys. Sinong mauuna? Andyan ba si Sir Gimo at si Sir Jaime? Si Sir Domi.
May kwala ako, may tanong konti. Ito ba?
Mahina ka, mahina. Ako ba ang mahina o ikaw ang mahina?
Ay, wako lang, again, okay na ba?
Mahina po.
Mahina po siya.
Madinis.
Para kang nasa loob ng kuweba, sir eh.
Ano kaya ito? Hello? Hello.
Mahina.
Ganon. Teka nga.
Ayan, medyo okay na yan.
Sige. Ito ba sa BMS natin analogo sa DCS or PLC?
Okay po, ang PLC you also can be used for, kasi mostly ginagamit na siya ngayon sa elevators and mostly for, so if you are talking about PLCs into the building management system. So some are using PLCs, programmable logic circuits. Tama po, pwede, you can use that depending on what you want to control in the system. Mostly PLCs are used in industrial settings, factories, manufacturing automation. Building management system, mostly digital controls, direct digital controllers.
Kasi mayroong continuous control and monitoring ka. So parang DCS, no?
Distributed, yes, distributed control systems. Tama po. So they are different, intertwined po, different terms, different vendors term it differently. But if you look at it, meron ka pong software, meron kang hardware, meron kang protocol. So in fact, if you have DCS and different, what do you call this? If your network architecture, that's what you call the DCS when you say direct control system, or I mean distributed control system. In fact, if you look at the system controller that I showed earlier, that is a DCS system. You've got one huge DCS on top, and you've got many different DDC around it. So that in effect is called a distributed control system.
Kasi I'm looking at Hansen on the cost-benefit ratio, no? Siyempre, kung dadalawang floors naman ang iyong kung ilalagyan mo pa ng siguro hindi. Ano minimum number of stories, floor area na medyo sasabihin natin na cost-effective itong paglalagay natin ng automation system for the building?
I believe po, kasi wala namang guideline on that. But first, you have to take care of the building envelope. So kailangan, sa smaller, this a huge place, a huge part. Plays a huge part in smaller buildings. No? Because I think you can put in the sensors that turn on and off lights for you. Kaya ngayon, napaka-uso po ngayon home automation. IoT, home automation. That's why today you can buy Zigbee systems. A lot of my friends are installing home automation because these are small ways you can actually save on energy. So kung meron mga sensors na ganito, you pay more. Like now you pay maybe 100,000 and so on for such systems. But over the years, it can save you. So ang idea po parati is that even if it's one floor, one unit, or mas malaki, 2 floors, if you have these control systems, in the long run, it can save you energy. That is why if you look at what's in the market today, home automation is in fact becoming a huge market because number one, when you have these systems, it can save you in the long run. So if a buyer, meron ka ng ability to pay for it, why don't you just pay it now? So it's like pay it now, recoup your investment later. So that's where you need to think. But in engineering wise po, or even in R&D, if you say meron ka bang data, if you look at yung senior ni Engineer Carl po in this regard, makikita nyo na automation really saves you. That's why in one of my slides, I also showed, emphasized that 25% savings. In fact, all of this automation, you have to implement demand supply, what do you call this? Demand and supply flow, meaning kung ano lang yung demand, yun lang yung kailangan mong i-consume. Kasi constant tayo ngayon eh. All of our homes constant eh. Pag umalis ako sa toilet, nakabukas, nakalimutan yung lights, edi gumagana yung ating meters. Sa atin maliit lang yan. But if you accumulate those over the years, dami, laki niyan. And in fact, ang laki niyan. Meron nga ako mali dito sa bahay when I made this house home. Hindi pala ito, but my virtual lang no? I should have used yung more efficient for water heating. Kasi over the years, it would have saved me a lot more. So,
mahal ka yung HVAC, HVAC.
We pay for all of those mistakes that we have done in the past. Kasi kung may ability ka naman to pay, why not install it today?
Oh, I see. Okay.
Yes, Sir Hansen. Yeah, I also experienced this automation in one of the hotels, mga big hotels. Yeah, they're using automation. There's a question from Sir Rusty Alegre. Sir Rusty, would you mind unmuting your microphone? It's about the sign and seal. Sir Rusty, are you still here with us? He's more into the sign and seal daw. Who would be the authority for the sign and seal? Sir Rusty? The full authority of sign and seal of the plans of this. Gusto mo mag-unmute, Sir Rusty? Okay, mamaya na siya. Balikan natin. Si Engineer Gay Soriano Tabao. Okay, from the Northern Luzon area. The automation topic is interesting. What are the current markets say about green buildings in the Philippines? Is it already part of their business model? If not, what are the measures or current policies that we can base on to practically do green buildings? Sir Hansen.
Okay po, so sa Philippines, meron po tayong green building code as mentioned by Sir Engineer Carl earlier. So let me just flash it again for the sake of Sir Soriano.
Generally, directions is for Go Green 2.
Yun.
Sir Carl is here with us.
Yeah. Almost all. We've been talking to developers also, no? Vertical or horizontal. Yes, they agree. They also know the direction. Going green is really the direction, and the government has already directed that. During the other day's presentation by Senator Win Gatchalian, securing the energy issues for the country. Well, part of which was tackled talaga, we have to be going into that directions, going renewables, going green, putting emphasis on climate change, and clean air.
Yep.
Diyan naman sa Green Building Code natin, specified naman yan. Okay? I hope
Yeah. To add more to that, this is just a slide showing the market nga, sabi nga ni Sir Soriano. What is the market? So in fact, green market is huge now, and DOE is promoting it as per DOE slide. So DOE ito, no? So they've got green building programs. They promote ESCOs. They promote all of this business in ESCO especially. Ngayon meron na tayong 25 plus ESCOs, and it's gonna grow, or maybe not, because konti lang want to go into the business. But a lot of this is because we want to be part of the reduction of the greenhouse gases emissions. So if you save a lot of energy consumption in buildings, that means you also contribute to the greenhouse gases. So the Philippines is there. It's just that siguro we're not hindi pa sobrang kasing bilis ng Singapore to push this. But we have people in the government who is pushing a lot more for energy efficiencies.
Okay, there's a question here from Engineer Rodel Manalo. Thank you daw for your presentation, Sir Hans. His question is, what protocol is your direct digital controller using?
Okay, so as mentioned, medyo brand agnostic tayo. You can use all of those different protocols. You can use Modbus, you can use BACnet, you can use even proprietary protocols if you want to. But sabi ko nga, better use the open standards that can talk from vendor to vendor, because you can really save a lot by choosing different components for your sensors, for your what do you call this, drives. You can integrate all of those. So depending on what you want to use. So also it's the engineer's job to kung saan ka what do you call this, fluent na controls, protocols. Okay, so because it involves the expertise of the engineer to program all of those controls, to be able to sequence the operation. So merong expertise that we need to understand in those protocols. So earlier in my presentation, I showed BACnet protocol.
Okay, thank you. Here's the question, by the way, Sir Hans, of Rusty Alegre, that he can no longer remember. Who will be the main authority now for the sign and seal of the design and installation?
The main authority, let me go back to that slide. Design and seal would be coming for, I think you're talking about the building envelope. Ano po? Design and seal is under the building
plans,
envelope.
yeah.
Of the plans, yeah. So that would be under architectural. So as you can see in the slide of the, let me show you the slide again. You can see this building permit process sa Philippines. This is talking about Philippines. It falls under architectural, building envelope.
But for electrical, kasi because
design and seal is more on electrical.
For electrical, yes. There should be delineation, electrical and electronic side. Kasi dito sa automation, yes, we deal with electronics, di ba? But for the electrical side, it should be the electrical engineer.
Yan na naman, EE saka ACE.
Issue yan.
Issue ulit ito sa atin. Tungkol dapat as early as now, introducing new technology, dapat na-draw na yung boundaries between the two. Kasi baka pag-aawayan na naman yan ng ating mga kabaro eh.
Yung delineation. Kaya nga, they are looking at the curriculum. If going back to the old curriculum of having electrical and electronics as one again, there are institutions or schools considering also that. Maraming pros and cons pa. But I guess for electrical, kasi syempre, hindi naman makatakbo yung electronic side mo without the electrical side.
Power
So,
supply, yeah.
yes. So it's more of the electrical.
Kasi
I
yung
go for the
electronics
electrical.
naka one system na sila So, yung power supply
Oo.
talagang kay EE. Okay. There's a comment from Engineer Gay Soriano who asked the question a while ago. Thank you, sirs. The building professionals of Region 2 are not that knowledgeable or even practicing green building design due to limitations in informations like this. Hope this kind of trainings or seminars be encouraged to all building professionals and decision makers such as politicians for us to protect our environment and not to exhaust the energy resources we have. Congrats to NLC and to yours too. Okay. So thank you for this topic. You opened the eyes of our kababayans that we have to shift to this automation. It's not just for conservation of energy, but it's a big help to our environment. And there's a question coming from Engineer Domi Degit. Is there any device available to be installed to residences of OFW families for energy savings? Residential, Sir Hans.
Ano daw po? Can you repeat the question?
Device daw for residential, automation for residential.
Oh, yeah. Is there, and the question is there a device for automation?
Yes, is there a
solution?
device?
Any device available to be installed to residences of OFW families? Meron na banggit niyo po yung OFW families. Ano?
Yeah. Baka gusto lang
So,
pati
I don't know kung ano.
sila lang makasave, lahat yan.
Oh, for energy savings. What does it mean? Can you elaborate more? Baka are you saying, is that for meter device or what?
Maybe a device maybe that they could control internet,
From
IoT,
abroad?
residential.
From
No.
abroad?
Maybe, Sir Domi, bigyan mo ako ng kwento from abroad, they could control, no? Para sa bahay nila dito locally. Sir Domi.
I am open ang aking.
Okay, sige, Sir Domi.
Ang akin kasi, sa dami-dami na mga OFWs na sa abroad, na they have families here and they have their own residences. Kung minsan iba nagre-reklamo ba't ang taas ng bill. So, kung tingnan mo, yung the way they handle energy consumption, hindi tama. Naiwanan yung ilaw, nakalimutan. Kaya kung meron tayong mga maliliit na mga gadget na we can sell to these families, total, kanilang mga family members na sa abroad, they can pay for that. Di ba? Yan ang aking kung ano mga gadget na pwede sa dami-dami ng OFW families. Ang nakita ko siya sa cooperative name, nakita malaking market ito. Malit nga lang. Not industrial. Yan lang.
Tama po, Sir Domi. Tama po. There are technologies, it's available already. Kung, if you think of, what do you call this? You want to see the energy consumption from away, control, that's part of home automation. Available po yung mga technologies po yan.
Yes, actually, nakita ko yan while we were in Nigeria. Huawei presented to us this type of technologies. We were in the capital of Abuja. That's far away from China. And yet, they send controls remotely. Parang yun si Alexa sa US. You can give instructions, Alexa, to play the music at this time or shut the light at this time. So it's just such devices pwede mo i-link. There are some, yes.
But cannot be done remotely, sir. No, maybe Sir Domi is thinking it can be controlled remotely if he is abroad, and then they would control their
Can be done remotely kasi what Huawei showed us, it was remotely done.
Okay.
They controlled it remotely.
So yun, Sir Domi, pag nakalimutan mo yung ilaw mo pag nasa abroad ka, pwede na pala.
Sir Domi, dati, correct. Sorry.
Okay, Sir Hans.
Sir Domi, in the past, yung mga mayayaman lang meron nitong technology, no? Yung remotely control, bago dumating ng bahay, malamig na yung bahay because they can control the aircon, the lights, and so on and so forth. But ngayon, because of the advancement in home automation and then the number of vendors and then the devices are also becoming cheaper, pwede na rin tayo especially for OFWs, these are within reach na po. Yung budgets that you wanna put into this automation. And it's easier for you to implement. So it really doesn't need a whole lot of expertise. Kasi sometimes they made these home automation systems very user-friendly. So plug and play na lang. Ganun po ang
Okay.
home automation.
Where can we find these gadgets, Sir Hans? Such as
I can-
plug and play. So we don't need to incorporate it into our panel just to have this.
Panel po? In
Yeah,
the
yung sa mga
meter?
electrical panels para
Well, you have to
mapagana
add,
siya.
you have to
Sabi mo plug
upgrade
and
your,
play lang eh.
Opo, plug
So
and play.
madali
Meaning,
na lang.
yeah, what I just say madali na, like you install these meters there and then you have the device, install mo dito wireless systems and so on.
Parang katulad ng
Connect.
Wi-Fi
That's what
booster.
I'm saying. Yes. You
Wi-Fi
can,
booster.
ibig sabihin, installation is easier. That is also for non-experts to be able to install this. So hindi mo na actually kailangan ngayon ng expertise ng mga engineers for home automation. So that's Zigbee. You can check out Zigbee. You can check out Zigbee is the protocol used in home automation, the wireless protocol. You can check this out. Marami sa Alibaba po. You can Google nyo lang po home automation, and you will have a lot of vendors.
Okay. Thank you. Wala ka palang na specific one sa amin para makatulong. Maybe we would like to try it sa mga bahay-bahay namin. Ba?
Yes.
Magandang maglaro.
Maganda po. Yeah.
Thank you for that. There's another question coming from Sir Engineer Edwin Giselle. Sir, based on system discipline design, subject respective system specialized engineer. Each system drawings and schematic design has each one discipline engineer. Hence, sign and sealed shall be done by the responsible licensed practicing specialized engineer for building automation system. There are engineers which are not specialized in the BMS, but they are signing and sealed. Hence, full responsibility is not achieved. This shall be carried by the qualified and specialized licensed engineer. Building automation system. Kanino ba under yan, Sir Carl?
Yan ang medyo vague area pa nga sa atin kung who
Gray area
will really answer for that. No? Logically speaking lang, looking at it, basta kung electrical supply, well, it's electrical. If it's the gadget itself, electronically operational lang, it's the electronics guy. On the automation side, well, electrical, years back, ang electrical engineer, meron na tayo automation eh. Meron na tayo mga ginagawang wiring connections, fully automated na
Pinakamahirap na
motors.
subject yata yan, yung feedback control eh.
Si Atoy nakikinig ata sa atin eh. Nagte-text sa akin eh.
Yan yata yung subject na parang ayaw kong pasukan na nun at talagang hindi ko maintindihan eh. Okay, Sir Jaime is raising his hand. Sir Jaime, you can unmute your microphone so that you can direct your question.
Good afternoon, sir. Good afternoon, ma'am.
Okay po.
Okay. Kanina naririnig ko nga yung sign and seal, ano, yung pinag-usapan. Actually, yun nga yung gray area na sinasabi ni Engineer Garcia na talagang napakahirap mahirap magpapirma. Basta na lang siya pumirma pero knowledge, wala. Walang iniwan doon sa electrical engineer, dalawang electrical engineer sa parte sa trabaho ko noon. Merong electrical engineer, merong protection engineer, merong isang klaseng engineer. Yung isang klaseng engineer, pabasahin mo ng schematic diagram ng substation, hindi niya makuha. Mabigat eh. Dahil diyan, logic kasi yan eh. Sa automation logic eh. Kailangan dyan talagang paano siya tumakbo eh. Malaban mo muna yung ginawa ni ECE, yung unit. Ano ba ang ano niya? Ano ba ang principle niya? Kaya kailangan talaga ang people magsasign ng seal dyan, sa tingin ko, yung talagang merong knowledge dyan. Dapat may mastery siya dyan. May master siya dyan na talaga siya pumipirma dyan. Nagsasign dyan, pumipirma siya. Hindi basta-basta PE ka, anything goes, pirma ka na lang. Hindi ganoon eh. Dapat hindi ganoon. Dapat yung PE, regulated din minsan dapat yan. Sorry sa mga ibang PE pero dapat regulated din eh. Si PE ng substation, tsaka si PE ng high-rise building. Papirmahin mo si PE ng high-rise building sa substation, may hirapan siya. Marami siyang hahanapin dokumento. Marami kung ano-ano. Pero kung pipirma doon, yung PE ng substation, madali na lang sa kanya. Vice versa rin yan. Kaya kailangan regulated din sila. Hindi lang porque PE pirma na, pwede na. Yun ang sa akin lang. Isa ko lang. Pero hindi yun tanong ko. May tanong talaga ako sa inyo.
Sige, Sir Jaime.
Actually, meron na ba kayo sister company sa Saudi Arabia? Wala pa ho?
Wala pa po, sir.
Wala pa. Bakit hindi nyo subukan? Maraming projects doon, maraming ano. Actually, yung late na na ginawaan ko ng substation. Substation projects kasi ako. 4 na substation yung ginawa ko roon. Green building din yun. Puro green building area. Kung tawagin namin yun, King Abdullah Financial District, green. Green siya. Ewan ko kung hanggang ngayon gumagawa pa sila ng mga building. At any rate, ang mga substation kasi namin indoor, marami inaano namin AHU. Ang substation kasi sa isang taon lumalabas ang project 10. Puro indoor, maraming AHU yan. Bakit hindi niyo subukan makipag sa Saudi Arabia? Baka makakita kayo ng Actually, meron kayo Netherlands, di ba? Maraming project.
Wala po kaming Netherlands, but we're very open to it. Nasa Saudi Arabia po ba kayo ngayon, Sir Jaime?
Kung gusto niyo, mabigyan kayo ng tao na pwede niyong kontakin. Yung actually best friend ko yun, nakasama ko sa trabaho, Vice President ng Alphanar ngayon. VP siya sa Sales and Marketing, VP Sales and Marketing Alphanar Construction. Baka matulungan din
business
kayo.
Opportunity for you, Sir Hansen, and your group. Maybe you
Thank you
could,
po, Sir Jaime. Opo, Ma'am Chi.
Dahil yun gumagawa rin sa power plant, may chiller din kami.
Ma'am Chi.
Baka baka masubukan nyo lang. Wala namang mawawala, makipag-communicate.
Yes po. In fact, Sir Jaime, if you could give us your contact, we want to contact your best
I
friend.
will give you, but I will not give. I will not give the personal cellphone number niya. Doon lang, makikita nyo naman doon sa sa LinkedIn ba yun?
LinkedIn, yeah. And Sir Jaime, we would like you, syempre, better for you to be involved as well.
Right?
We're open for partnership, Sir Jaime.
Yeah, makipag-ano kayo. Baka yung company namin na inaanuhan nila, kinukuha na nila ng trabaho, nagre-require na rin yan. Dahil marami talaga kaming AHU sa substation.
Oh, yeah.
So it's a business opportunity for your group, Sir Hansen. Maybe you could explore this recommendation or suggestion by Sir Jaime. Thank you, Sir Jaime. Kasi Sir Domi, he wants to ask a question.
Hindi question tungkol na dyan. Nasalam kay Mr. Engineer Jaime na tungkol na dyan sa prospects for business in Middle East. Dahil yung uli kong inalisan na kung Filipino company ito, mayroon na silang project sa Dubai, mayroon